Hi there. We're going to talk about acids and bases today. Two of the definitions that will come into play are Arrhenius and Bronsted-Lowry. We'll focus mostly on the second one, Bronsted-Lowry definition. And then there's a third one, Lewis, acids, bases, and we're not going to go into that. Arrhenius was one of the first scientists to recognize that some compounds, not all, had similar characteristics, and he defined acids as something that produced H plus when in water, so when in an aqueous solution. And then he said that a base, and this should kind of jive with what you already know, he said that a base produced OH minus or hydroxide ions when in an aqueous solution. So the one kind of limitation with the Arrhenius acid-base definition is that it has to be in water. So Bronsted-Lowry broadened the definition a little bit to include more things. So the Bronsted-Lowry definition does just that. So an acid, according to the Bronsted-Lowry definition, says that it is a substance that is simply an H plus donor. So think about like donating blood. You give it away. So a substance that gives away an H plus. Now this H plus has another term, and it's often called a proton. Now I know you've heard that word before, so I'm going to explain why we call it a proton in just a minute. But by definition, an acid, according to Bronsted-Lowry theory, is a proton donor or an H plus donor. So the opposite of donation is to take in or to accept. So a Bronsted-Lowry base is an H plus acceptor or taker, but we call it an acceptor. And again, instead of saying H plus, a lot of time we use the term proton, a proton acceptor. So let me talk about this term proton, because you're probably thinking, okay, yeah, that's what one of the things in the nucleus, and it's kind of what gives an atom its identity, right? Atomic number tells you what element you have. But what we are talking about here is basically hydrogen. So hydrogen has an atomic number of 1, which you're very familiar with, and the most prevalent isotope of hydrogen actually has no neutrons. So like over 99% of hydrogen atoms have 0 neutrons and 1 proton. So that would actually give most hydrogen atoms a mass number of 1. So this means that there's 1 proton in a hydrogen. There are typically 0 neutrons in a hydrogen atom. And then if we have an H plus, that means that we have 1 fewer electron than protons. So we also have 0 electrons. So if you take a look at this, the only thing that we really have, the only subatomic particle in an H plus is a proton. So that's why they can be used synonymously. So I don't care if you call it H plus, I don't care if you call it hydrogen ion, or I don't care if you call it proton. Any of those is an appropriate term. One last definition I want to go over right now is something called a hydronium ion. Okay, so say that word a couple of times, hydronium. So this whole proton H plus thing I just talked about, it's really unstable on its own. And what's always going to be around, or most of the time going to be around, because most acid-base reactions are going to happen in aqueous solution, are lots of water molecules. So the hydrogen ion hooks up with water molecules that are around it, and it gives us what is called the hydronium ion, which is an H3O positive. So it's basically a water molecule with an H plus added onto it. So that's what's called a hydronium ion, and you'll see that often.